Alrighty, kids. So we are here for the third day of our conics unit. We are working with worksheet 7-3, okay? We're going to be covering section 11.2 in your textbook, okay? This is covering parabolas, okay? So we've talked about parabolas before. However, there is another perspective at which you can look at parabolas, and that's as a conic section, which you watched the video about, you know, where you had the cone, and you cut the cone on the side and then perpendicular to the base, and it created a parabolic shape when that very interesting gentleman cut it. There's another definition which he also talked about, which is the locus of points related to the various types of conic sections that we're going to talk about. And that's when he used the string, okay? So the definition of a parabola as a locus of points is a set of all points in a plane, okay, that are equidistant to what's called a directrix. That's just the line, okay? Okay. And a fixed point, okay? So the focus is a point, all right? Not on the line. So if you take a look, here's our parabola, okay? There's still going to be a vertex like we're used to, but if you take a look here, every point, okay, so here's our first point, here's our second point. So from point 1, if I measure the distance here from the focus to that point, and then from that point to the directrix, which is just a line, okay, those distances will be equal, okay? And then as I continue up on the parabola, the distance increases, but the distance from this focus to this directrix, right, is the same, okay, to that point. So if I choose another point, let's say over here, right, this perpendicular always, because if you remember in geometry, from a point to a line, you always measure perpendicularly. This distance, right, will be equal to the straight distance to the focus, okay? So every point is equally distant to the focus and to the directrix, okay? Now, when we write the equation of a parabola, usually we're used to ax squared plus bx plus c, or maybe vertex form. There is another form, okay? And this is the standard form of the equation of a parabola when we're talking about a conic section, okay? So the key thing here is we're going to keep talking about distance. That's the biggest thing, okay, when we graph these parabolas, all right? So the focus lies on the axis p units, right, from the vertex. So, and then we're going to also graph the directrix p units, all right? So where is this p coming from? Okay, so this is the most basic parabola equation that you can have. X squared equals 4p, okay? 4p is going to be a distance, okay? Always think of that as a distance. That is a constant 4p. It's always like that. Your book uses 4a, just so you know, all right? It just really doesn't matter, but it's always 4 times some constant, all right? That's our distance. Now notice I switch it up here, which is something we really don't see, we haven't seen, where I have a y squared. Now what does that do to my graph? Well, just like we're used to, x squared and y squared, those create parabolas, okay? So if I have an x squared equals 4py, okay? What that's going to mean to me is the parabola is going to be, and this is just a general characteristics, it's going to be shape facing up with a vertex of 0, 0, okay? And then the two critical things that you're going to have to graph in addition to that is your focus and your directrix, okay? Now, those are always p distance away. So if I look here, up here, this distance from the vertex, okay, to the focus is always a p distance, all right? Now that p distance comes from 4p, okay? So we're gonna solve for that, and when we get to graphing, you'll see, all right? And then also your directrix is always gonna be p distance away, all right? So my focus for this one would be here, okay, and I'm going to usually use an X for that so that you don't think it's a graphed point, okay? And then my directrix would be down here, okay? and that would be p distance away. Now, if it happens that it is an x squared, right, equals, but this value of 4p is negative, what that does, so I still have a 4p and a y. My x squared always makes it face up or down, like we're used to, okay? But similar to like the a value being negative, making it face down, now it's going to be the 4p value is going to be negative, and then my parabola is going to be facing down, okay? So that's if 4p is negative. So negative 4p, and then this is if it's a positive 4p. All right, and then again, my focus is always inside the parabola, so I would have a focus here, and then I'd have a directrix somewhere up here, okay? Again, those would be a distance of p from the vertex, all right? Now, you have also a case where it's a y squared, okay? And I think we may have seen this briefly, okay? But if I have a y squared, all right, that means my parabola is going to be opening left or right, all right? Now, my vertex is still going to be 0, 0. But now, when I look at 4p, if 4p is positive, then that means my parabola is going to be opening up to the right. Okay, and again, my focus is going to be here in the middle of the parabola, and then my directrix is going to be on the left-hand side, all right, that line. Okay, I'm not graphing them right now. We're going to get into graphing them in a minute. If I have a negative 4p, okay, then that means my vertex is still 0, 0, okay? I'm then going to open this up to the left, okay? So this guy is going to open left. So negative means left. So similar to the example over here, if 4p is negative, my parabola is going to open down. Now my parabola is going to open to the left. But this is different because of the y squared, all right? And then again, my focus would be inside here, and we'll talk about finding that distance in a bit. And then my directrix would be on the other side. But what I want you to focus on this page is looking at what's squared, and then whether or not 4p is positive or negative, because that dictates the directionality of it, right? Whether up, down, left, right, okay? So that's super important, all right? Now, if we make the equation slightly more complicated, and it's gonna look more complicated, and if this is confusing to you, don't worry, we're gonna be doing this for more than one day, all right? Now, wow, okay, this is my equation, all right? So I've changed it ever so slightly, but all I want you to see is, do you see how now I just have an H and a K? Well, the H and the K now, I'm shifting this from 0, 0, the vertex, and I'm shifting it left or right, and then up or down. This is just my transformational form. So what you have to remember here is your vertex is always HK. And remember, it's always the opposite signs than the ones that you see in the equation because of that subtraction sign in the equation, all right? Then these are x squareds, right? So you can see the quantity being squared on the left-hand side in that parenthesis is the x squared, so that's why my parabola is facing either up or down, okay? So this is when we have a positive 4p, this is when we have a negative 4p, okay? And then, just like here they're using this fancy term, right? P is greater than 0. Here, P is less than 0. That's just whether or not it's positive or negative. So if P is positive, right, then we're going to have it facing up. So positive 4P, right, facing up. And then here, if P is less than 0, that just means we have a negative 4P. Okay, that's all they mean by that. All right, and then your directrix, right, these distances, this is always P, and this distance from the vertex is always P, all right? And then here is going to be P, and then there is going to be P, okay? So the distance to the vertex is the most important point, right? We're going to graph that first. I'm going to go through graphing an example here, okay? So x squared, right? X squared and a positive 4p tells you it goes this way. x squared and a negative 4p tells you it's facing down, okay? And then p is always distance to from vertex, I should say from vertex to focus and directrix. I don't know who came up with all these names, but that's our names. Okay. You're going to see the focus come up again in our next shapes, all right? Now, if you take a look here, so this guy, we had an x squared, right? Now we have a y squared. So like we said, yes, on the previous page, right? We're always going to find our vertex. Okay, so if you see no pluses and minuses here, then your vertex is just at the origin, 0, 0. But now it's going to be HK in this case. And then if we have a y squared and a positive 4p, right? Then we're going to open to the right. Open right, okay? And then if I have a y squared but a negative 4p, that means I'm going to open to the left. And that's what they're saying here. Yours might not be color-coded, but in the pink, okay? So if p is less than 0, okay, so this is a negative 4p. This is a positive 4p, okay? And then your distances, again, this is always p. That's always p, right? Because we're going to the directrix and to the focus. And I'm going to put an x there. And then this is p, and then that's p, okay? So the directionality is super important, okay? P is always a distance. So when I actually calculate P, I'm never gonna use the negative because distance is never negative, but the negative is gonna determine my directionality, okay? So let's take a look at the first one, okay? So I take a look at this guy. I know this one is going to be a parabola because there's a squared term, right? A squared term 1, all right? Now, the first thing you should always do is think about what this is going to look like, all right, before we plot any points. So since it's a y squared and I have a negative 4p value, and again, you don't have to write this. Maybe at the beginning you might want to, but this is what you should be thinking, okay? Y squared, 4p is negative. That means that it's going to look like this, right? It's going to open to the left, okay? That's the first thing. Then the second thing I would do is find my vertex, okay? So if you remember, this should be this formula, right? Okay, so H and K are my vertex. So this is my H, right? There's a K here, but there's nothing being subtracted from that, so that's just 0. These are always the opposite signs. I don't distribute the negative 4, okay? Just look at the parentheses. So my vertex here is going to be negative 3, 0, okay? So we got that. Then I'm going to take a look here, and since I know which way it's opening, then the third thing I'm going to find is find P. So if I'm going to ignore the negative because I use that negative here for the directionality, it's just really the value, like the magnitude of that value that I want to use. So 4 equals 4p. So therefore P is 1. So that's my distance. Sorry about that. To vertex. To focus and directrix. Okay? So let's go ahead and graph that. So here I have negative 3, 0. That's my vertex. I'm going to put a little V there. Okay. Then I have my P, right? So that's going to, I know this is going to open, we said this way, right? So if it's opening this way, my directrix has to be inside. So this, sorry, my focus has to be inside. So that's my focus. So now I have, this is the stuff they're going to be asking for on the homework. That's my vertex, right? My focus is going to be 1 unit to the left of that because it's going to be opening left. So that means this is negative 3, 0, so my focus is negative 4, 0, okay? And you can just use an F, that's fine. And then my directrix is going to be on the opposite side, 1 unit, right, because of P, 1 unit to the right. So my directrix is a line, never a value, so make sure you're writing the equation of a line. And since it's vertical, right, it's going to be x equals, and that's going to be -2. So those are the 3 things that your textbook is going to be looking for, all right? So it's not enough just to graph, you actually have to give me those values. Now, how the heck do I graph this if I only have 1 actual point on this parabola? Okay, here's the deal. To determine the width of this parabola, what you're going to do is you're going to use the value of 4p, not the negative value, right? Because we're going to be talking 4p is a distance. We're going to use that value of 4. So the width of this parabola is going to be 4, okay? Now, how do I use that? Well, here's the deal. You're going to have what's called a lattice rectum. That's right. I have no idea who came up with the name, but that's the name. A lattice rectum with a length of 4 units, okay? What that means is you're going to go from the focus 2 units up and 2 units down, okay? So 2 units to the left. Oh, I should say up, 2 units up, and down from the focus. Okay, so you're counting from the focus and kind of splitting it. So 2 units up, 2 units down. That then, and notice I created those as points, all right? So that will create the width of our parabola. Okay, so that's what we're looking like there, all right? So the book doesn't actually ask for this, but you should have that, all right? Because otherwise, how wide is this parabola, okay? So sometimes you might want to label those, okay? So that would be, what, -4, 2, and then -4, -2. Okay, sometimes I might just tell you the length of the lattice rectum, okay, and say it's that many units, okay, which is again just the value of 4p, and that will tell you the width of the parabola, okay? So that's our first parabola. Let's try another, okay? We got 2 more, all right? So take a look at this guy, all right, number 2, okay? So number 2, let me just make sure you can see it. Okay, so number 2, what I'm looking at right away, first thing is the directionality. So if I look, this has an x squared. So since it has an x squared and then 4p is positive, then that tells me that this guy is going to be facing up, right? X squared determines up or down, right? Then the 4p being positive means it's got to go up, okay? The second thing I want is my vertex. So if I look here, if I see any pluses or minuses, that's my vertex, okay? So if it's just without any pluses or minuses in the parentheses, then you just have a 0, 0 vertex, which you will have on your homework, okay? So this guy, my vertex will be 1, -2, always opposite signs. So there's my vertex. Okay, that's one thing your textbook will look for. Okay, so we got that. Then third thing, right, is I gotta find P, right? Because that's gonna determine my focus and my directrix. So 4P equals that value, so this guy is always 4P outside the parentheses in factored form, okay? So I divide by 4, so this is 2, so P is 2, okay? So that means when I go to graph this, if I go to 1, -2, that's my vertex, okay? My distance P is 2, so that means it's gonna be opening up like this, so my focus is actually here, okay? So my focus is gonna be 1, 0. And my directrix is going to be 2 units below that vertex, so it's gonna be here So now I'm creating a locus of points, right? Equidistant, so it's 2 units away here, 2 units away there, okay? And then to determine how wide this is, right? I know the lattice rectum, or the LR, all right, is 8, okay? So that means from the focus, I'm gonna go 4 to the right and then 4 to the left, or vice versa. I said it backwards. Okay, so focus 1, 2, 3, 4. Then focus 1, 2, 3, 4. So really, I'm graphing a second and third point, right? This one's going to be at 5, 0. And then this one's going to be at -3, 0. Okay? So now my parabola is much wider because my 4p value is bigger than it was in the previous example. And that is my parabola right there. Okay? All right, last one. So this looks a little funky, okay? And you can see this one down here we're going to talk about tomorrow, okay? But this one, I can see it's going to be a parabola because I've got a single quantity squared there, okay? So I'm going to isolate the quantity squared. Now, you don't have to do this on the homework. You will the next day, but just so you know, that's what we're going to try and do. So write this in what's called our standard form. So isolate, right? The squared quantity. So I'm going to just move this whole shebang over. So I'm going to add 16x minus 4. They're all attached, right? So I can just add that whole entire quantity, just like you would add 16x, right? Because you're adding the coefficient. All right, so now I've got y plus 3 quantity squared equals 16x minus 4. I'm going to leave it in factored form, and therefore I can see that this should be, right, a parabola to the right, because y squared, the quantity is y squared. I have a positive 4p, so that tells me I'm going to be opening up to the right, okay? I also know my vertex, okay, is going to be 4. Make sure you pay attention. The x coordinate is always with the x, so that's going to be 4 comma -3. So that's my vertex. Then the third thing we always find is my 4p. So 4p, and again, the 4p never changes, okay? So that coefficient to the non-squared term is always your 4p. So 4p equals 16, so p is 4, okay? So my distance to my focus and my directrix is going to be 4. So if I go ahead and graph this, I'm going to have 4, 1, 2, 3, 4, -3. So there's my vertex, okay? I'm going to be opening up this way, okay? So I know my p-value is 1, 2, 3, 4. So my focus is going to be inside that parabola. So it's going to be on the right-hand side of that vertex. And then my directrix is going to be 1, 2, 3, 4. That's actually okay. So this guy, my focus, right, what did we say here? So really I'm just changing, right, the x values, aren't I, by 4. So my focus is really 8 comma -3, isn't it, right? Because my distance p, I'm moving it to the right, so it's 8 comma -3. And then my directrix, right, that's going to be, I start here at a value of 4, we're going to move to the right, so I'm going to subtract 4, so really it's x equals 0. And I just realized I forgot to write the directrix here. This should be y equals -4. All right, and then how wide is this guy, right? Well, wow, okay, it's going to be 16 units wide, okay? So the length of our lattice rectum is going to be 16 units. So that means I'm going to count 8 units from the focus up and 8 down. So 1, 2, 3. Okay, then 1, 2, 3, 4, 5, 6, 7, 8. Oh, look at that, fits perfectly. Okay, so now you can see that is pretty far, or pretty wide, I should say, okay? But that is our parabola, okay? I am writing my focus and my directrix here, okay? You can also put it on your graph, that's up to you. But I should see each of these values, okay, on your homework. Again, your homework does not ask you for the latus rectum, but I should see that on your work, okay, because that determines how wide this parabola should be. So there should be 3 points on your parabola. I should see your focus, okay. Again, I put it as an X because that's not actually a point on our parabola. And then we have our directrix, always a dotted line, because it's not necessarily a part of the parabola, it just determines the shape of the parabola, okay? So try your homework, it's from the textbook. Graph each of these, make sure you're stating the necessary characteristics, and we will continue with the rest of this worksheet next class, all right? Hope you guys are doing well.